Okay, today we're going to preview lesson 6. So we're going to talk about all the things that you need to know before we begin lesson 6. So go ahead and take notes as we do this lesson. The first thing, oops, let's clear all of that. Sorry. So today we're going to just do a preview lesson of lesson 6.1. This is all the information that you need to know before you begin chapter 6. So let's go through this. The first thing we want to talk about is what is a solution. So if you think of a solution to an equation, if you think of a simple one-step equation, you can think of a solution as if I have x plus 3 equals 7. You can look at this and you know that by subtracting 3 from both sides, you get x equals 4. 4 is what we call a solution to the equation x plus 3 equals 7. It's what makes the equation true or makes it work. So in this case, you're looking for what values of x, because that's our variable, that when you plug them in, it will equal 7. Well, there's only one, and that's positive 4. If you move on to a solution to a linear equation, say you have y equals 2x minus 3, a solution to that would be any value of x that when you plug it in, you get the value for y. So we've made tables for this. And we say, well, when x is 0, y is negative 3. And when x is 1, y is negative 1. And when x is 2, y is 1. And when x is 3, y is 6, 3, etc. So here, these are all solutions. They're points. They're all solutions to the equation. So in a linear equation, that's an xy equation, the solution are points on the line. So if I graphed this, y equals 2x minus 3, the points that the solutions to it, let me pull up a graph here. Whoops, sorry. My stylus doesn't want to work today. If I pull up a graph and I graph y equals 2x minus 3, that means my y-intercept is at negative 3 and my slope is 2 over 1. All of these would be solutions to that equation, any one of these points. So 1, negative 1 would be 1, 2, positive 1, 3, positive 3. They would all be solutions, along with all the decimal solutions in between. They would also be solutions to the graph. When you have an equation that looks like x, my stylus is in slow motion. Say I have 3x equals 2x plus x. And you solve that and you get 3x equals 3x or x equals x. We learned in that case that there are infinite solutions, which means it doesn't matter what you plug in for x, it is always going to work. And if you remember, we also had a no solution, and that happens when you have something like x plus 1 equals x minus, or my stylus slowed down here, 2x minus x plus 1 plus 11. So we go ahead and solve this by combining like terms. We get x plus 11. We subtract x from both sides. Those cancel. We get 1 equals 11. And we know that 1 does not equal 11. So we say that's no solution. That means there's no value for x that when you plug it in, this equation will be true. Using those, one solution, infinite solution, no solution, we are going to be solving more than one equation. So make sure you understand no solution, infinite solution, one solution, and what a solution represents on a linear graph.